Welcome back, everybody. Mr. Renneker here again. And this week we're going to start into Chapter 9, which focuses on surface area and volume. What that means is that we're going to be focused a bit on three-dimensional or 3D figures here for a little while. And in this specific lesson, we are going to focus on finding the surface area of prisms. So by the time we are done with this lesson, we should be able to find the surface area of a prism using a formula specifically, which we'll discover here shortly. Let's get into it. So our first key idea, it revolves around the surface area of specifically what we call a rectangular prism. And it's often what we picture when we think about prisms. We're going to clarify what a prism really is shortly. So when we talk about the surface area of a prism, this says the surface area, which we'll call S, of a rectangular prism is the sum, meaning we're going to add, sum of the areas of the bases, which we'll need to define, and then the things called the lateral faces. So we can see here in our diagram, we've got two versions of a rectangular prism. Here on the left, we have a three-dimensional version, a put-together version. And then you see that they labeled each one of the dimensions or the measurements using a variable to represent it. This first one, that's a cursive L, represents the length of the front face. Then we have W for width, of course, and H for height. Over here on the right, though, we have something called a net, or sometimes it's also referred to as a flat pattern, simply because it's like we're peeling off the surface of our three-dimensional figure, in this case a prism, and laying it out flat. You'll notice here that some of the faces are color coordinated. For example, these two bases here, those are both red, just like you see in the three-dimensional figure. A base is actually defined when we have a prism as the shape that we have exactly two copies of. Notice that we have exactly two of those red rectangles. Here's the first one, here's our second one, and that's what will make it the base. When we look at other prisms like triangular prisms or even pentagonal prisms and so on, whatever shape you have exactly and only two of, meaning one pair, that's what helps define what a base is. A lateral face, those are the faces that are surrounding the rest of the prism, almost like they're wrapping around it, if you will. It's also the faces that connect the two bases. So you can see here we have one, two, three, we have four lateral faces. Those are the ones over here on the three-dimensional figure, like here on the right side. There's one on the left side. We have the front and, of course, another one on the back. It's those four faces, again, that connect the two bases. Now, one little side note for you guys before we get too much further in is that base does not mean top and bottom. Now, of course, in this picture, it seems to. Of course, the base is right here on the top. The other one would be underneath on the bottom, which you can't see right now. It looks like it's the top and bottom, but that doesn't necessarily have to be the case. Think of it this way. If we had a soda can, just like this guy here, of course, we can envision the top of the soda can and the bottom of the soda can, the top and bottom. Those would be your bases. They're circles in this case, of course. But if our soda can fell over, like this. Just because the can now is laying on its side or its lateral face, it doesn't mean that these, the top here and the top here are no longer the bases. Of course, they're still the bases. So keep that in mind with prisms. Again, there's one circle here and one on the other side that you can't see. Those would be the bases here. So when we look at prisms, whatever you have exactly two of, that's what defines our base. So back to our rectangular prisms. So we are understanding a little bit about three-dimensional figures, their dimensions, and their nets. But we're going to start by using this formula here to help us find the total surface area, meaning the sum of all the areas that cover the figure. So in the formula here, we see 2LW plus 2LH plus 2WH. Now the reason that we're using that type formula is simply because when we look at our flat pattern or our net over here, you notice that there's a total of 1, 2, 3, 4, 5, 6 total faces on the surface of our figure. And when you look at the formula, this first part describes 2 of the faces. The middle one here, the LH, there's 2 of those, so 4 total faces. And then when we have 2 at the end, there's 2, 2, and 2 makes all 6 faces that are on the figure. Now the LW part and the LH and the WH, that's just simply how we calculate the area of any rectangle, which we can see here. That's the shape of every face on a rectangular prism. They're just rectangles. So we take their two sides and multiply them together to find, well, their area. So we're going to apply that in our first example. So here in example 1, we're finding the surface area of a rectangular prism, which you guys can see clearly marked here. We're going to go ahead and make sure we're clear on what the dimensions are, meaning I always like to label the one in the front as the length, the one that's typically on the right side as the width, and of course the one that would be over here on the right-hand side, which is the same as the 6 inches, that was what we label as our height. I want to make sure I know what my variables are before I continue. Now, oftentimes they're going to recommend that you start by drawing a net or a flat pattern to help you envision the shapes of all of the surfaces. In this case, a net for this prism would look like this. And again, that just helps you envision all 6 of the surfaces on a rectangular prism, and also helps you see some of the dimensions as they kind of spread out. But notice, initially, the dimensions were 3 inches, 5 inches, and 6, and that's exactly what we see here on our net as well. So nothing's changed. It's just a different way to envision this box, if you will. It's just like, and especially in this case, I guess it's just like perhaps taking apart a cereal box or the cardboard outer shell of it. And with enough practice, some of you might be able to actually envision what the net looks like without drawing it every time. But for most or all of us, that is going to take some practice first. Once you have it, though, you can see the formula here. And ultimately, what we're doing is we're simply going to substitute in our dimensions, our length, our width, and our height for the appropriate locations of our formula. So we start off here by finding the surface area by taking 2 times the length times the width. And the length down here we see is 3 inches, so 2 times 3 times the width, which is 5 inches. And then we're going to do that for each part of the formula as we go through it. I'm going to spread these out to help us see each one. So we've got the first 2 times length times width, that's right here. And then next we'll do 2 times length times height. So 2 times the length again is 3 inches, but the height is actually 6. And finally, we have 2 times the width times the height. So we're taking 2 times the width of 5 inches times the height of 6 inches. Now again, I just want to point out here that we are taking 2 times the dimensions here because there's an equivalent surface for each one of the ones we see here in the 3-dimensional figure, meaning if there's a front, well, there's also a back, and they're identical. If there's a top, there's going to be a bottom, and they're identical. If there's a right-hand side, there's also a left-hand side, and they're identical. So instead of actually calculating 6 separate surfaces for a rectangular prism, we ended up just finding one area here, one area here, one area here, and doubling it, in essence, is what we're doing. With that in mind, we can go ahead and just do our calculations for these surfaces. 2 times 3 times 5 should be 30, and in this case it is square inches. And 2 times 3 times 6, well, that's 36 square inches. And lastly, we have 2 times 5 times 6, and that should be 60 square inches. Then remember that to find surface area, we're finding the sum of all of our surfaces, so we do need to add up these pairs that we have here. So 30 plus 36 plus 60, which leads us to a total surface area of 126 square inches. So I strongly recommend that if you have not already, you make sure that this formula is in your notes. It is going to be heavily used for part of this first lesson, but we are going to move on to different types of prisms because you won't only see these rectangular prisms the whole time. Before that, I'm going to go ahead and give you a chance to try a couple of these rectangular prisms on your own and finding their surface area. If you'd like to practice before moving on to take a look at triangular prisms, go ahead and try these 2 problems on your own, again finding the surface area using the formula from the previous slides. If you're going to try these, go ahead and pause the video now, and then in a few more moments, your solutions will appear for you to double check. Okay, so for number one, you should have ended up with a total surface area of 52 square feet. And for number two, you would have ended up with a total surface area of 288 meters squared. If you had any difficulty or some confusion that you can't identify on your own, please let me know as you work on your assignments or before then, and I'll be happy to help you out. Next, let's take a look at some different prisms. Now, in general, prisms have two bases and then they have some number of lateral faces. That number, which I'm calling n here, that n comes from the number of sides that are on the bases. So if the bases were triangles, well, triangles have three sides, so n would equal 3. But if the base was, for example, a hexagon, which there would be two of, well, hexagons have six sides, so there would be six lateral faces. Our key idea here says then that the surface area, S, of any prism is, again, the sum, so we'll still be adding the areas of the bases, again, always two of those, and the lateral faces. And the number of lateral faces, again, will change depending on the shape of the base. And while we could use this idea for those other, we'll say, fun-looking prisms, for our lessons here during remote learning, we are going to only focus on triangular prisms. So here we'll be finding the surface area of that triangular prism, which you can see in the picture. And again, finding the surface area of any prism is simply going to be found by taking the area of the bases, and to that we're going to add the areas of all the lateral, which I'm going to abbreviate, faces. Using the idea from just a moment ago, keep in mind that means we're going to add up two shapes, two flat surfaces for the bases, plus some number of lateral faces. Now, I said a moment ago that that number of lateral faces comes from the number of sides on the base. Now, the base is the shape that there are exactly two of. So as you look at our image here, notice that there's one triangle appears to be on the top here, and one triangle hidden on the bottom. We have exactly two triangles here. That means those are our bases. And how many sides are on a triangle? Of course, three, which means we're going to add three lateral faces up as well. That'll just help you keep track of, well, did I do enough faces? Did I calculate too many? And things like that. You'll also be asked perhaps to draw a net or imagine a net if that's possible to you. And our net would look something like this. Looks a bit odd compared to our rectangular prism net from a few moments ago. But here we can see clearly we've got our two triangles, which clearly makes our bases. And then the three other faces are still just rectangles. Folks, that will always be the case with a prism. In this point or at this point in your mathematical careers, the connecting faces of a prism are just going to be rectangles. So we'll start to find these areas in just a moment, but before I get there, I would like you guys to take note of the fact that while there are one, two, three different rectangles, they all end up set in a kind of a row here, if you can see that, which really means that it's possible, although not necessary, it is possible to envision those three rectangles as just one continuous rectangle. Of course, one side is 6 meters, but the other long side is actually a sum of these three numbers. Notice that those three numbers are actually the same as the three sides of the triangles, or at least one of them here. That idea is going to come back to help us here in just a little bit. Okay, here we go. So to find the area of the bases, again, we have two of those. So whatever calculation I do, I'm going to multiply by 2. But since the base is actually a triangle, remember to find the area of a triangle, we take 1/2 of the base of the triangle times the height of the triangle. Now, in this case, looking at the red triangles on our image, keep in mind that the base and the height of a triangle are perpendicular, meaning they have to meet at a right angle. And you can see it right here at the top, hopefully, that we have this side kind of on the front and this side on the right. Those are going to be where we get our base and our height from. So you have to be careful identifying those. Now the base then, over here in the front, that would be 3 meters, so 1/2 times 3. And then the height, again, being on the right, that is 4 meters from the bottom. So we have 1/2 of the base times the height, times 2 to get both of them. And you should end up with a total area for the bases of 12 square meters. Next for the lateral faces. And again, you can see them here in our picture, and you saw them on the net just a little bit ago as three separate rectangles. And you're more than welcome to calculate those rectangles, or the area of those rectangles, I'm sorry, one at a time. For example, we could simply say, hey, there's a green rectangle here on the front, and it is 3 meters by 6 meters. I could calculate that area pretty quickly. But I'm going to encourage you guys to go ahead and try to find the area of all the lateral faces in one step. Now remember that that one long rectangle that I pointed out, that had a height of 6 still, but then the long side came from the lengths of the sides of the base. In other words, if we find the perimeter, P for perimeter, of our base, we can simply multiply that by the height of our prism to find all of the surface areas of the lateral faces in one step. Let's see if it works here. First, to find our perimeter. The perimeter of the base, we've got a 5-meter side up here on the top. We have the 4-meter side here on the right. And in the front here, we have a 3-meter side. So 5 plus 4, which is 9, plus 3 more is 12. So we had a total perimeter of that triangle of 12 meters. And we're going to multiply that by the height of the actual prism. Now, the height of a prism is the distance between the bases. So it's basically the distance that says how far apart are the triangles, and that's 6 meters. And with that one calculation, folks, you can find the surface area of all the lateral faces all at one time. 12 times 6 is actually 72, and that'll still be square meters, and we end up with a total surface area of 12 plus 72, or 84 square meters. So I would encourage you guys, again, before we go on to the next step and get ready to wrap up our video here, to make sure you have this version, or this formula, I should say, for the surface area of a triangular prism to help you guys be as efficient as you can. I'm going to give you the chance to try on your own here in just a moment. Okay, here are a couple on your own problems. Again, finding the surface area of, you can see, both triangular prisms. Just as a quick side note before you try on your own, number 3 and 4, you can see they're turned a little bit differently. Number 3 is not too bad, but when you look at number 4, it's almost like the prism is on its side. Notice how you have this triangle on the front, and then you have this one way in the back over here. Keep in mind that the triangles are the bases. So when you go to use your formula, and you go to find the area of the lateral faces, which asks you to take the perimeter times the height of the prism. Height, that's the distance between the triangles, the distance between the bases. And that can be a little confusing because when we think about height, we're thinking about how tall something is. But this side over here is not the height of the prism. In fact, it would be this edge down here, because that distance shows the distance between the triangle in the front and the one here on the back. So just keep that in mind. Go ahead and pause the video if you want to try on your own, and your answers will appear here shortly. And here we are. Number 3 should have had a surface area of 150 square meters, and for number 4, 60 square centimeters. Be careful with triangular prisms. They are tricky for many people to start off with. A lot of us forget, for example, when finding the area of the base, which is a triangle in these situations, that you have to do 1/2 of base times height. A lot of us forget the 1/2, and that might be something you should double check if you had trouble getting to these solutions. Otherwise, we are all done with this first section of finding surface area of prisms only. We got to use formulas both for rectangular prisms, and then we introduced one for triangular prisms as well. Be patient with these ones. I would recommend perhaps having a calculator handy just to avoid silly errors. And as always, let me know what help you might need, and I will see you next time.